Paul, again, a fantastic guy. I've actually sat in on his presentation once already. He may not know this or remember it, but we recently had an event up in North Houston called A-Day. We had 1,700 attendees. It was a fantastic event. And Paul gave the next to last presentation at A-Day. I gave the last one. And Paul's was pretty much on what you can see with your telescope. And this one is sort of a variant of what he talked about at A-Day. Here it's called Celestron Origin. Thoughts after a year, C-star S52. Just to give you a little idea of some of the formal things that Paul has done. Wow, how do you like that? Physics, Greek, and Latin. That's a fantastic combination, guy. You're working both sides of the brain, left side and right side. Okay. I have to confess, what is NRAO?
National Radio Astronomy Observatory.
The National Radio Astronomy Observatory in New Mexico. And he has a
VLA, yeah.
Okay. A master's degree in electrical engineering studying optics. Interesting stuff. Illuminators for photolithography. Software engineering manager for the Discovery Channel Telescope project at Lowell Observatory. I love that. Now, here's something that is really cool to me. NASA, I work with IBM. NASA is one of my customers. And so I work with a lot of NASA staff and a lot of NASA customers. And my particular area of expertise is model-based systems engineering.
There you go.
So we need to talk about this sometimes. Okay. With respect to smart telescopes, he's really done a lot in the past, almost 2 years now. He began in February 2024 working with a C-star, and then he moved over to his Celestron Origin, and he's been using an Origin for about a year. Is that true? Maybe a little bit less?
On the year.
Okay. And like it says, an MBSC, Model-Based Systems Engineering, the acronym for that is MBSC. So if you hear anybody talk about MBSC, basically it's what Paul does. Gateway VSM. And like it indicates that you've done a lot of cool work. I guess control-based software would be like embedded software development.
Yeah, real-time controls for
fantastic
Discovery Channel telescope, so including the active optics system and all that good stuff.
Fantastic, fantastic. Well, I'm going to sit down, shut up, and let you come up here and talk to us about what you got.
It's better up there or here.
You can be up there. I will drive it.
Yeah, however you want it. However you want to do it, Paul. However you want to do it. Okay.
That'll work.
Okay, can everyone hear me online? All right, excellent. So first, thank you, Todd, for inviting me to speak, and thank everyone for being here. I know we're competing with the first game of the World Series. I'll try to get you out by the 14th inning. All right, anyway, we'll see what we do. So we're going to talk about the origin, and at the end, we'll talk a little bit about the C-star. This is, of course, an image of M33. We'll talk about that in a minute anyway. Let's go ahead. This is what the origin looks like in my backyard. And that's one configuration. So the origin itself is a 6-inch RASA, which is Rowe Ackerman Schmidt astrograph, and it's an f2.2 telescope. So we're not aiming to get super high resolution, perhaps, but it is excellent for astrophotography. There is no eyepiece option in this particular version of the smart telescope. It's entirely imaging, but the optics are fantastic. Okay, next slide. Okay, the sensor on it is a 6 megapixel sensor. That's the camera, versus 2 megapixels for the C-star, just so you know. All right, let's keep going.
Paul, raise your volume a little bit for those who are here in the audience.
Okay, yeah, okay. Let's keep going. Okay, the mount is a modified Nexstar Evolution mount. So it's not the same as, it's not quite a stock Evolution mount because the Wi-Fi in this case is in the optical tube assembly. You connect a cable between the mount and the, well, let's take a cable here, connects to the optical tube, and then the process, most of the processing is in the camera, obviously, etc. The processing is in the optical tube, and it has a lithium-ion battery. and it says 6+ hours. I think I've exceeded that and not had a lot of not a lot of issues. One interesting point is that the app doesn't tell you a lot about the battery. It just kind of tells you high, medium, low. That's about it. Whereas the C-Star kind of gives you a percent. You can argue about how accurate it is, but both of them have plenty of battery, and if you really need to, you can run either of them and charge them at the same time. So not really an issue, I think. Okay. So usually I set it up I used to set it up with either one of these mounts. So the mount on the left comes with it. I also bought the tabletop tripod, particularly to take to George Observatory or something like that. It's just easier to throw in the car. But in the end, I end up using the stand-up one because that's a little more secure, and it just seems a little better. And then they have captive screws that connect the mount to the tripod, and then again you just connect the optical tube assembly with the dovetail to the mount, and then connect the aux cable, and you're ready to go. So that's it. No eyepieces, no power cables, no USB cables to the camera or anything like that, and you're ready. Okay. Can everyone hear me or not? Okay. Okay, we'll keep going. All right, so operation, pretty much you have it ready to go. You take it outside, you turn it on, and the origin figures out where it's pointing using a plate solver, which isn't exactly what it does, but it's close enough. And then it automatically even controls the dew heater. The C-Star has a dew heater, but you have to turn it on and off. Go ahead. So by plate solver, it used to be really that you would take an image and then you would run some software and figure out what you were looking at. That's kind of what it does. It's just not strictly speaking a plate solver anymore. But essentially, it takes an image, it looks at what the stars are in the field, and it figures out where it's pointing. So if you don't have to point it, you can be pointing basically anywhere. You kind of point it up in the sky and just say, go ahead, and you turn it on, and it knows where it is. It focuses itself. It's ready to go. Okay. Go to the next slide. Oh, do you want me to click it? Oh, okay. Oh, okay. Yeah, so then you open the app on your device and you wait for initialization to complete and you're ready to go. I use a tablet that actually I've had tablets before, well, sort of one or two, but I never used them. Now that I have the C-Star and the Origin, I use this thing all the time because it's a big enough screen people can see. Not exactly as high quality an image as it is on my cell phone, but it's still very good. All right, let's see if I can get this to work. Okay, go ahead. All right, so now, as about 2 months ago, I guess, they came out with supporting the wedge tripod, and it works fine. So basically, I go out there, put them out, with the wedge on it. Well, like you said, we have to figure out which way north is, and then I bring out the telescope. So a little different scenario, but not much. And I connect with it. So turn it on. Okay, next slide.
So Paul, before we move on, I have a question for you. How close do you need to be to north for it to work in that mode?
So to be captured, I think so. For the Altaz, it says you have to be within about 5 degrees of level. So I'm presuming it's about 5 degrees to the capture. And then what you do is you run the normal, it's really a different kind of initialization. And then whenever it finishes, it says, hey, you need to perform equatorial alignment, polar alignment. So you don't need to point to the North Pole. It's still pointing up there. It does an image, a couple images, tells you which way to go, basically. And then you have an app and you align it. You align it, and go ahead to the next slide.
So you end up eventually with the wedge aligned with the North Celestial
Correct.
Pole. Okay.
Right.
All right. Got it.
Actually, I thought I had a picture there. I'll just show it later. But yeah, so well, there's another image later on where we walk through it. But yeah, it helps you center it right on the north equatorial North Pole. That's it. So once you are aligned and initialized, then all you really have to do is select the target, command to move. The telescope moves itself to that target, and you can select the target from a map that they have. It's based on, let me think what it is, but I'm trying to remember what app it is, but anyway, so you just pick the target off the map, or you can search the list of targets either by category or just type something in. You can enter user-entered coordinates, user-defined coordinates, RA and DEC basically, or anything really. It's very easy to select anything. All right, and we can go on to the next slide. And once you're there, it tells you ready to image. You click the image screen, and then you click again because it shows you a kind of a semi-real-time picture image, and then you click to start integrating the image. And you wait until it looks good, and then you click to stop the imaging and download and etc. And then if you don't want to do that, you can create a schedule. I'm not crazy about the interface that they have on the Origin, partly because once you say you can add things to the Origin, to the schedule, you can add them from the list of things. You can say, here, let's pick a target, and you can say, let's add that to the schedule, for instance. And you can add them. You can edit the schedule and the duration of time, etc. And then you click go. Well, it doesn't give you any indication. It just disappears, but it's running. So it's not maybe the best interface, and there are some times when things don't happen quite the way you expect them to, and that's true of the app in general. Having said that, it does work, and it's really cool. So,
so I have yet another question.
Yeah.
Okay. So, have you used other sequencing software like Nina or Sequence Generator Pro?
I have not.
Okay.
Not with any of these. The C-Star also has one. I haven't used that one, to be honest. So, but the C-Star does have a.
Okay, I was just want to ask how you might compare what
I don't have
the Origin has right now with the others, and that's okay.
Yeah, there's not. Yeah, it's pretty simple. You add elements. You can add a specific time, or go in the sequence, and then you can add the duration that you want to add in, and all that. There's just not a whole lot to it really, but anyway, that's it on that. So you can change the filter. It comes with the default filter is just they call it a clear filter, but I think they don't really tell you a lot about it, to be honest. But I think it's more or less some rejection of light pollution, but I'm not really sure. Maybe it really is truly clear. But you're not supposed to operate it without some kind of filter. The other filter that you can buy separately that Orion sells, they kind of say this is the only one you need, but other people do buy particularly other types of nebula filters. But there's an Origin nebula filter. To change it, you have to take off the cap, the dew shield basically, and then you take out the filter. The filter is in this is screwed into the filter assembly, and the filter assembly you just have to very carefully put it back in there. It connects with magnets, and it works fine. It's a little scary to do in the dark, but not terribly, and but it does take a couple minutes to do this. So I know some people they started selling now just the eyepiece, this part here. So people buy multiple of those, and then they just swap the whole assembly, which probably makes sense, but I haven't done that.
So yet another question. Do you know about what's the size of the filter? Is it like similar to a 1 1/4 inch filter, or is it similar to a 2-inch filter?
This one is a 1 1/4 inch filter. The filter assembly supports either 1 1/4 or 2-inch.
Okay, all right. Do you have any sense as whether or not it would be able to accept just standard third-party
Yes,
filters?
they can. Yeah.
Okay.
And people do use it.
Good. Thank you.
I have a question.
Yes.
Steve, hold it.
Is there any focusing required?
So every time you do change the filter, then it asks you to, it would reach, you tell it you change the filter, and it refocuses. You do have to remember to click the button that says you change the filter. That's just pretty easy to remember. So, all right, go on to the next slide. All right, just a thing here. The Origin doesn't ship with an instruction manual. It ships with kind of a quick start guide. And it doesn't doesn't mention the manual, but you can presume that there is one, and you go and download it from the website. It's kind of obvious, but I wish they would kind of mention that. I asked them about that, and they just said, well, we want everybody to get the latest version, which makes sense. But I kind of thought they should at least mention it. But anyway, they don't. But anyway, it's kind of obvious still. The performance, well, it's very efficient. It's when you tell it to go to the object, as long as there aren't clouds or buildings in the way, it centers the object. And it does support reframing, by the way. If you want to image a different part of the thing or just move it in a different part of the image, you can do that. And the imaging is very efficient in that. Well, the C-star is not efficient in that sense. If you image for the elapsed time could be an hour, or let's say 30 minutes, but the actual integration time is much less than that, because the C-star tends to discard many images as being there too much motion or whatever. The Origin is almost that the integration time is almost equal to the duration, to the elapsed time. It's not quite. I set a timer. I was trying to do a mosaic, which I haven't put the images together, but I could not put them in the schedule because the scheduler doesn't support RA deck targets, and I wanted to enter specific RA index. So I was doing this manually, and anyway, I said, okay, I was trying to do more or less 26-minute exposures. So I set a timer, and it was a little bit, I had a little extra time at the end. So it's not 100% efficient, 100% exact, but it's very, very efficient. And it's F2.2 system, so you can get images really open clusters. The default that Celestron has for the Origin are 5 minutes, 10 minutes, and 20 minutes for these different targets. And the tracking is excellent, really superb, actually. And rarely do you see a message that it's discarded because of clouds or anything when there really are clouds or something. That does happen, but not very often. All right, and well, for Astronomy Day, I gave the talk. I listened to Todd's talk, and then I went out, and they were almost shutting down. But I said, okay, let me set this up. And people at the talks and people had asked about M20, so I'm like, well, let me just point it at M20. Well, it was that high above the horizon towards the city. Couldn't see any stars there, and I'm like, all right, well, let's just see what happens. After 5 minutes, I had a pretty reasonable exposure of M20. It's like, well, that's not bad considering what the circumstances. So it's pretty impressive. All right, let's go on to the next slide. Anyway, images look good to me directly. I mean, there are probably many of you take much better photos, for sure. But the big built-in image processing is pretty cool because you get something you can look at pretty right away, really. You can obtain the raw images. Downloading them, there's a USB-A connector. Apparently it takes a very long time to get them down. And then more recently, I said latest release. Well, that was when I made the slide. It's a little bit, it's been a while now, but you use Wi-Fi now, using an FTP to get the raw images and process them. I will say that just from what I've observed, just looking at Facebook or something, there are many people who are post-processing C-star S50 images and doing amazing things. I don't see as many people post-processing Origin, and I think part of that is it's just the images look pretty good out of the box, out of the telescope initially. All right, let's go on. So sharing photos, once you have an image, It pops up on the screen, and you save it, and you can select the metadata to include on the image. So you can put the name of the thing, the date it was, where you were when you took it, the duration of the exposure, that kind of thing. And then it does give you an option to crop it, and it's basically a free form rectangle. So it does fit to a rectangle, but any kind of rectangle. I would like them to have some kind of preset shapes, at least, if not sizes, because I think it would be nice to keep it kind of consistent, but it's not. But it's really cool that you can do that. And then whenever, note here is kind of annoying, but every time you save the image, well, at least I save it to Google Photos in my case, every time it does that, it essentially leaves the app and it comes back and it tries to reconnect to the telescope. So it's a little annoying, but it's not a big deal. Well, I don't think I get the messages much anymore. Anyway, it's not a huge deal. So lunar and planetary imaging are not its strengths because it's an f2.2 telescope, but I'll show you what it can do. And when I do take an image of the solar system object like that, well, a planet, then the cropping does not do it in the origin. Well, first of all, it takes a snapshot. You can't crop it in the origin app because it's a different process. But I open it up in, for instance, Google Photos and zoom way in, and you can get something pretty decent out of it. And like the Sea Star, it's similar to the Sea Star. It doesn't track a comet, it tracks the stars around everything sidereal tracking. So if you take a long exposure photograph of a comet, yeah, it will definitely trail. All right. So you can still take a number of images, of course, and stack them. So, yeah. Questions? Okay. Yeah.
Perhaps you covered it, but I saw it looked like you had the option of doing alt azimuth or equatorial.
Yes.
Why, with the scope, would you choose one or the other?
Okay. Can you just hold on? I'll get to that because I have another slide on it, and then I'll answer it then. If not, then yell at me and I'll do it again. No support. So it does not have, the Origin does not have support for solar imaging. There is no solar filter for it. I asked Celestron. They said, yeah, we don't have one. We don't intend to make. Before I even bought the telescope, they said, yeah, and they said, no, we're not going to do that. Of course, you could make your own, but the other thing is it won't do the initialization. You can use it during the day, but of course, it's not going to track. You'd have to figure out how to point it where you want it to. And you can use it during the day, but it would be okay to point it to things that you can easily either stationary or you can slow enough that you can track it. But there's nothing that you can use to track it. Sea Star is a little bit better there, and obviously while it is fairly lightweight, it's not something I want to take on a hike. All right, so let's go to the next slide. I didn't find that the Wi-Fi connection was the best. Like the Sea Star, you can either connect to your network or it creates its own network, and you can connect to that. What I did though in my home is I just use these Wi-Fi. I have different kinds of range extenders and set them all up in a mesh network, and then I can be anywhere and I can connect to it. When I go to George Observatory, I either connect it to my phone or I connect to the Wi-Fi on the telescope.
So just as a point of clarity, so what you're talking about there is having the telescope set up its own Wi-Fi network and you're using its network?
That's correct.
Okay. For instance, like for controlling it using your tablet or something like that.
Correct.
Okay. Got it. Thank you.
Yes. So you always connect to it with a device, a tablet or phone, and you can either connect where the telescope connects to your home network or your cell phone network, a hotspot, and then your device is connected to that as well. You say your home network, or you have and the Sea Star works the same way. The telescope sets up its own network, and you just connect to that directly. But then you can't connect to the web to the internet with your device that's connected to it. So, right. Actually, can we go back one slide? Oh yeah, I did want to make this point that sometimes, actually, still today, the app if you use it for some time, every once in a while, after a while, it starts slowing down, and you're trying to type something in or trying to even move on the map, and it just doesn't really move. Not a problem really, because you just shut it down, shut down the app, reopen it, and it's fine. It's kind of annoying, but not a big deal. All right, so thank you. We can go on to the next slide. All right, so then they do sell an optical tube assembly bag for the Origin. Highly recommend that. I did actually have it kind of fall a little bit once, and the bag did protect it. It wasn't far, but that's good that I had it. It's a very nice bag. The mount, and here I mean, yeah, the mount that goes on top of the tripod. They do not have really a product for that, but I found that somebody online on one of the, I think, Cloudy Nights mentioned a food delivery bag, and this is the only one I found that was just the perfect size. It fits the foam inserts that ship with it perfectly, and it's great. And then, obviously tabletop tripod or the thing. Honestly, I don't have a bag for those. I just put them in the trunk of my car and we're fine. I have to take off the spreader bar, but anyway, no big deal. Nothing really unique to Origin on that. All right, go on. Oh, okay. So support for expansion. The camera is upgradable. I'll talk about that in 1 second. Let's go on to the next slide. Have any control of this? Okay. Right now, the Celestron does not support video or video stacking or time lapse. It does not currently support a mosaic mode, but Celestron says they're working on that, and they also say they're working on labeling of objects in the field. Okay, we'll go ahead. Okay, so now it supports an equatorial wedge. There should be a photo there, but maybe not. Okay, once assembled, we talked about what we do to polar align it until we get to here. So an image of the app there, screen. Anyway, it shows you where you are. Oh, that's just with the wedge. Oh, let's see. Did I just turn off my volume? Can anyone still hear me? Uh-oh. Did I do that wrong?
No. You're okay.
All right. So the app indicates an alignment error. The one thing is you have to use an Allen wrench to unlock the azimuth, which isn't a huge deal, but you have to have an Allen wrench. And then the altitude, you just twist a screw basically, and it works fine. And then it does after you realign it, then it has to do another initialization. Okay, we can go on to the next slide. All right, so this hopefully answers your question. Advantages of polar alignment. As Celestron says, it does help because you don't have image rotation. Sure. Now, when you have image rotation, the app automatically stacks the images. It's just at the edges of the image that it's not exposed evenly. So it ends up being, you can see some rough things around the edges, especially when you get near to the zenith. And the second thing is, so you kind of have a consistent orientation and no image rotation if you have the polar aligned telescope. And obviously you can image at zenith, which is the darkest spot generally. So that's a help. And there's a third advantage that Celestron says that you can do longer individual exposures. But they also say the default is 10 seconds, and they said there's really no advantage to going over 30 seconds. I still just use 10 seconds. Maybe there's an advantage, I don't know. And then the disadvantage is, well, it's just a few extra minutes to set up versus just plopping it down, turning it on, you're ready to go, kind of. Now you have to point the telescope north, and you have to go through the polar alignment procedure. So it is a few extra steps, but I don't know. I will say that I'm kind of, I don't know, hooked on doing the polar alignment. I think it's I like just being able to image as long as I want, kind of type thing. All right, let's go on to the next slide. All right, and you can also, Origin, as of a couple months ago, same time they supported the equatorial mode, they also introduced support for the StarSense Auto Guider. I haven't tried this, partly because it's, I don't know, it's $700, I think it is, something that I don't have. But secondly, it's, I'm not sure that it really does much for you, especially if you're doing 10-second exposures, and it's basically working as a guider anyway. So I'm not sure there's a whole lot of advantage, but could be wrong.
So just to clarify, the auto guider is a capability for minutely adjusting the telescope to keep it on target?
Yes.
Okay.
Yeah. So yeah, they have a StarSense Auto Guider, which kind of does the same pointing thing, but I think at a higher rate, basically. Versus the telescope is, as out of the box, is correcting your position every 10 seconds anyway and stacking. So I'm not sure there's a whole lot of reason to do that. But all right, let's keep going. How much time do I have left?
About 20-25 minutes.
Okay. So I just took some images early on when I got the telescope. So to compare them, backyard versus a much darker sky. My backyard's not bright at all, not dark at all. But anyway, you can see some of the kind of make out most of the stars, most of the main stars of Sagittarius, kind of, but that's about it. So the one on the left here is from my backyard, and the one on the right is from Martin Dyes State Park in the Piney Woods up there. So it's definitely better on the right, but it's also pretty amazing what you can do from backyard. All right, let's go on to the next slide. Here's M67. The background tends to be a little bit darker if you go a little bit farther out. And this was Junction, Texas. This is at State Park, South Yana River State Park, which is an international dark sky park. All right, or however, I may not be saying that right, but anyway. And again, the Black Eye Galaxy, definitely better in a darker sky, but also pretty impressive what you can do in your backyard. All right, let's keep going. M51. So I've cropped a little bit differently, but you can see a little bit of the. Of course, it depends upon the night. Some of these weren't, obviously the sky quality matters too. But anyway, we'll keep going. Carlsbad. This was out by Carlsbad Caverns, and let's keep going. So I'll just kind of go through this kind of quickly, but this is a sense of what you can see from near to far. And then I want to save a little time for the sea star, so we'll skip some of these. But anyway, here's the moon, and we keep going to the next one. This is what the moon looks like. If I keep going, this is a full moon image, and I use this to kind of show folks, the audience. Go ahead. What the different Maria are, and you can kind of keep clicking through on because we're going to name each one of the Maria. That we have. You can just keep going on clicking through. And anyway, explain what each one of those are, and we can keep going. Yeah. And then talked about the craters. So Tycho and Copernicus. So I think you can keep going. An interesting tidbit is the Tycho formed during the Cretaceous period, so when the dinosaurs were still around. That's how recent that is. And then we've got Proclus here over by Mare Crisium, and then I think the next one is going to be, they have Aristarchus here, and I think Copernicus. They have Plato here and Copernicus in the end. Yeah, there we go. A couple of two peaks there, and the Copernicus. We can keep going. So you can see the Schrader's Valley here, and some features of mountains here, basically, in the Alpine Valley. So, enough to see these things, but I'm interested to see one of the new. Well, I'll talk about that in a second. Actually, I haven't talked about that. That's what you can see. The planet this is probably my best image of Jupiter. Obviously, there are much better photos, but on the other hand, we can see some features. If we kind of scroll through, we can see the Great White Spot. We can see the north and south equatorial belts, and many of the zones, etc. So they're kind of all there. Thank you, Harvey. And keep going. Okay, Saturn. Well, the rings are edge on, so we'll see what interesting to see what we can do later. But for right now, that's what Saturn itself looks like. But we can image many of the moons. So one night I took one image and kind of blew out the overexposed Saturn, and then took a deeper exposure. Let's go ahead. And you can see that I think we have 1, 2, 3, 4, 5. I think 7 of the moons here that we're able to capture pretty easily. And then you can keep going. Can't see all 274 of them, that's for sure. But anyway, then we've got, let's keep going. We're still learning about, okay, so we've got Uranus, we can see Titania and Oberon, and if we keep going to Neptune, it's pretty easy to see Triton, and very easy to see Pluto, capture Pluto, and watch it move from night to night. Doesn't move very fast. Asteroid, I don't think I have a video that just kind of shows it bouncing back and forth. Oh, they might play. Let's see what happens. Yeah, Hebe. I just took a couple exposures. This was with Altaz mount, and you can kind of see it moving. So anyway, and comets. Last October, November time frame, we had Chuchensan Atlas. And that was my best photo with the origin. And then more recently, we had Atlas fading in, just now faded into the horizon, more or less, into the western night sky. And then we've got you can see at least our interstellar visitor Atlas here, 3i Atlas. Not exciting, but it doesn't look like much, but it was able to capture it. All right, and then star 61 Cygni, which was the first star that had its parallax measured. And then we've got, I think, Alberio next. No, Vega, just a bright star. We can just kind of cruise through. And we're moving farther away again. A double star, maybe optical, or it's either a very, very, very long period physical binary or an optical binary. I'm not sure. And then keep going. Betelgeuse. And you can see the deep red of the garnet star here in Cepheus. Keep going. Here's a nova, Vulpecula, Nova Vulpeculae, and then here are the Pleiades with the reflection nebula. The Pleiades are just passing through the nebula here, and they're next to the gas and dust and lighting it up. All right, we can keep going. Some other open clusters as we move farther and farther away. Just keep going. M46 I like just because you also have the NGC 2438 in front of it, which is a planetary. And then keep going. Double cluster.
Oh, that is beautiful. This past Saturday night at the George, we actually looked at the double cluster through the 14-inch SET that's in the West Dome with an eyepiece, and I have to say that's much more lovely than what we were showing our audience with the eyepiece. That is beautiful.
And Caroline's Rose, okay, and a supernova remnant. So here we've got the Western Veil, and I think we have the Eastern Veil next. Here. And of course, I think we're going to have after that, keep going. Yeah, that's true. Supernova 10 to 20,000 years ago. This one obviously much more recent, 1054, I think it is.
So,
And
Paul, let's just go back to the crab for a second, if you don't
Yeah.
mind, Hari. Okay. So how much exposure do you have there? Not a whole lot. It's only,
710 seconds.
it's less than 12 minutes.
Yeah.
Okay. That's not bad for 12 minutes. Okay.
Yeah, and you can pick out the central star, although it's difficult to pick out exactly because there are a lot of things in there. Yeah, Helix Nebula, the dumbbell, or I actually like the name the apple core better because I think it looks more like an apple core. But anyway, so we're seeing a lot of planetaries as we move farther out. Ring Nebula, it's okay. I haven't found a way to get it exposed very well.
Well, and also you only exposed it for 9 minutes.
Yeah. Well, if you do longer than that, it blows it all out. So eventually,
Okay.
so and I haven't found a way to capture everything. That's what.
Okay. All right. So
in
what you might try for things like that. I don't know if you've ever tried your hand at post-processing,
I haven't, but yeah, you can do that.
but Cyril or PixInsight or something like that.
Yeah.
You can you specialize processing to de-emphasize the brighter parts of the image and make it so that the dimmer parts will show through well.
Absolutely, and a lot of opportunities there. All right. Flame Nebula here.
Flame.
Horsehead, and Running Man, or however. Actually, I don't know what that one. I can go back to that one. I actually think it looks like Bigfoot. We've got a couple eyes here. Whatever, but anyway. So. Kind of keep going, yeah.
Rosette is one of my favorites.
Yeah, it's beautiful. And now we're moving beyond kind of the next arms of our galaxies, and we're in the halo, so we can start seeing some of the more than 150 globular clusters that belong to the Milky Way. And then moving farther out, we see our near neighbor, 2.5 million light years away. That's the Andromeda Galaxy. This is obviously just the core of it. So, like I said, I did take a number of exposures. I saw online somebody recommended using that's I guess telescopius.com is what they said. So you can pick out the RA index. So I just entered the RA index, took the exposures. Now I have to stack them, stitch them together. Hopefully, Origin, Celestron will add that feature, so it'll do it automatically, but it does not yet. So,
and that's only 11 minutes of exposure right there.
Yeah.
That's pretty good for 11 minutes.
I have much longer ones, but yeah, that one is, that's all you really need to start off with. And yeah, I made a point here that some of the first really radial velocity measurements of galaxies was made by Vesta Slifer at Lowell Observatory where I used to work. And of course, this one is coming towards us. So it didn't show it's our near neighbor. So locally, we're moving towards each other. Obviously, as we move out into the other galaxies, we see more of the cosmological redshift. And M33, Pinwheel Galaxy, this one's 3 million light years away, but still in our local group. And then we get to the next kind of groups, a couple of groups. One is the Sculptor group, and this is the galaxy that is known for it. And then the M81 group, which has M82. It's a little bit closer. Starburst Galaxy is a little bit closer than M81. And those, I think, were taken out at, well, that one's not. Okay, never mind. Yeah, go ahead.
I see in this image, it says El Paso and Carlsbad. Does that mean you took images from both locations and put them together?
No, I don't know exactly why it says. I think it's just saying that we're somewhere between El Paso. It does it automatically.
All right.
We're in Carlsbad, camping near the national park, and then we're just moving farther away, but still hanging out in the Virgo supercluster of galaxies. So we are. I think that one's pretty amazing. It's just the galaxy. And I also have an image, when I left Lowell Observatory, they gave me an image of that one. So I can compare the two, and it's kind of cool. With a 4.3 meter telescope and with the Origin. So, obviously the 4.3 meter telescope is better, but, and we did actually look through the DCT, Discovery Channel Telescope, with an eyepiece at one point, but anyway. There's the sombrero. We'll keep on going. We're nearing the end here. But the Virgo A galaxy, obviously it's an elliptical galaxy, maybe not the most amazingly, there's not a whole lot to see there, although we can see here the jet that goes on for, what is it, I think 1,500 light years or something like that, using synchrotron radiation, basically. That's why that works. And there are several trillion stars in the galaxy, and at the center, a supermassive black hole that's it has basically a few billion solar masses in it. So,
Wow. Wow.
4,900 light years long. In fact, it looks like it's super relativistic, but it's only because of the angle we're looking at it. And the ice galaxies are also in Virgo. That's close up, just cropping it actually. And then M100, M90, 10A galaxies. All right, so then this one I just wanted to point out. So this one I just took these are the Stephan's Quartet, and then also here is NGC 7331 we'll look at in a second. And in this case, I just put them in a tool called ASCAP, and it tells you what's in the field. And if you look, I think all of them except one have really do have a point of light or something like that. You can tell you're really looking at the thing. So, although it doesn't really know that, but it just, anyway, so they're all there. And then the next one, I think we're actually going to look at 7331 because it had a supernova this summer. And so that's one of the images of the supernova. I watched it, slowly dim, basically. It's still there. So they tell us the Origin app itself.
Paul, could you repeat the question? Most people probably couldn't
The
hear
question is whether, good point. The question is whether or not I do any denoising on these images. The answer is I don't, but the app does. So you can configure the app to do whatever you want. Honestly, I just use the default values because I'm happy with it. So you could, there definitely, if you use less noising or whatever denoising, etc., I'm sure there are other fainter details you could pull out. But I kind of like it, so I don't really mess with it. But no, I don't do anything extra for these images. You can get the raw images and you can do whatever you want. And just more supernovae. This one is Cygnus A radio galaxy. I put this in here partly because I just wanted to see if I could image it. This is what I was making images of when I was working at NRIO that summer, which if you look at it is the third brightest radio source in the sky, and it has lobes, whatever, in a giant active galactic nucleus. So it's about 600 million light years away, and I was able to image it and see a little shape here, structure, but it doesn't look like much. All right, but I could see it easily. And then the next one is that's the redshift, 0.056. There's the redshift. How far the spectrum is redshifted. And then the quasar, so there's an article in Sky and Telescope not very long ago, I don't know, a few months ago, maybe 6 months ago, that says, hey, this is probably the farthest quasar you can see in an amateur radio telescope. So I thought, well, let's see if we can find it, and it wasn't hard at all. But I'm not sure it's the farthest thing, in fact, but we'll see. But anyway, this is really quite far out there. Okay, and okay, before I go to this one, I will say there's an extra slide that a week and a half ago, Celestron released Mark II of the Origin, and just last week, and they have now a new camera for that. So if you want, now that's the whole point of having this telescope, is you can upgrade the camera. So basically, we have to buy the camera, install it ourselves, and play with it. So the new camera is supposed to be higher resolution, smaller pixels, higher resolution, better noise, signal noise ratio, and the frame is supposed to fill the entire standard image kind of type thing. So we'll see. I'm sure I'll get this some point, probably sooner rather than later, because the new app that came out also, it forces you. Well, it tells you, it gives you an error. You can still image with it, but it tells you that you need to do darks, which is no problem. You just say go ahead, but you also need to do a flat frame. So you can buy, you can do various things, but there's a third party that does sell a flat frame generator for the Origin. So probably do that. All right, and yeah, as I said, I use it. All right, so probably over my time. So
Take about 5 more minutes.
you can forgive me for, okay. That's I think all I need. So this is obviously with the C-Star you can do solar imaging, which is great. This is it also does the time-lapse photography, so you can make time-lapse video. That's straight out of the Origin that I did there. In retrospect, I probably would have taken more exposures rather than less, but you can see the solar prominences here, et cetera, et cetera. So we were happy to do that. You can see obviously the sunspots. This is our gigantic sunspot cluster that we had in May of 2024. But you can see the details, obviously the penumbra and penumbra of the different sunspots. Yeah, we can keep going. That's fine. Here's just the moon with the C-Star. Still pretty decent. You can also take videos and stack them. I didn't find that it was any better, but maybe I'm not doing it right or something like that. But it does, the feature works, but I didn't find that it just gave me a whole lot better image. We can keep going. This is the horse head in the thing, and what you're seeing mostly is that if you get to the noise question, because the C-Star is really pretty decent, but they're obviously not as much detail, but there's also a lot more noise. But now the C-Star has a denoise feature as well, there's, and like I say, I've seen people post-process the images and make them super amazing. So, all right, just some more images from that, just so you can compare. And the C-Star does have a feature where it will label the different objects for you, so you can do it right in the app. And I say denoise was applied here. I'm not sure I did it correctly, so I'm not really sure. I clicked the denoise button, but I think you're supposed to do more than that. So I shouldn't go too much into that. But anyway, it is cropped. And now when you crop it, it gives you some standard sizes, and it even puts the labels on, like actually, so does the Celestron Origin. So anyway, and then these are comparisons between Origin, obviously, and C-Star. They're both good. Obviously, I like the Origin better just because it's more capable to optical system, obviously, but in the end. But the most obvious thing is the denoise. So yeah. Okay, on my website, I do have detailed technical comparisons of the cameras, the optics, etc., if you're interested in that. And I do have a website that has information about the equipment, and also just lots and lots of photos and things, and mostly about astronomy, but also, wildlife as well. So that's kind of what I do. Is we travel to different state parks and stuff, places. So anyway, that's really all I had, I think. So
That's a
Thank you
pretty
for
good
your time.
bit. So let me ask a question. Who has the first question?
Okay, so there's many similarities to these two scopes in terms of what it produces. There are definitely some differences. What's the difference in cost?
the Sea Star is about $500. The Origin, well, the new Origin is about $4,200. And you got to spend a little bit more because the Sea Star comes with a case. Comes with a case that's about this big, and it includes the solar filter and really everything you need. You can buy some things. I did the only thing I've really bought, the accessory that I have bought that I find useful is a leveler for the Sea Star. You can put it on a leveler to just help, gives me some flexibility to fine tune the leveling of the mount. Otherwise, everything you need in the Sea Star is in that box, and the little leveler fits in the box too. For the Origin, yes, it's $44,200 now, but you also need the filter and you need the bag. I would say at least those two things. So it's a few $100s more than that $4,200 before you get to the equivalent of the Sea Star in terms of, I would say, functionality. So.
But my observation is you are incredibly enthusiastic about the Origin.
I am. Yes. I like the Sea Star. I am incredibly enthusiastic about that because you can take it anywhere. But yeah, if I have either one, okay. I used the Origin last weekend because we were on a scouting camping trip, and I could just throw it out there, and I wasn't too worried about the kids running around. But for the most part, yeah, if I can use one, well, the images are better out of the Origin. So, and they're that extra step better that I'm pretty satisfied with them. Now, of course, yeah, sure. When they make a 12-inch one, and someday I can afford one or something like that, I can ask them.
So
I did ask them initially,
Yeah.
are you ever going to make an 8-inch one? We didn't get an answer to that one.
So one observation that I would have is that, say, for somebody who thinks they might enjoy astronomy, the Sea Star would probably be a great first acquisition.
Yeah,
And then if they find out they're a little bit more serious, then maybe consider the Origin.
yes. And if you like to do lots of image processing, I would do the Sea Star. Now, with the Sea Star, they've also introduced the S30, which I think most people thought they would go bigger, but they didn't. They went smaller, but it's kind of cool because they have maybe a better camera, but also a wider field. So you get the whole say M42 region and et cetera. And it's a pretty nifty telescope. I don't have it, but I've seen that on thing. And the other thing is the Sea Star you can take somewhere and image during the day. It will even track things during the day, imaging. So you're saying I've seen a video where somebody's tracking a boat having the Sea Star track a boat, for instance, going across the water. So you can take it on a hike, take pictures that way. But yeah, on the other hand, the Origin's pretty lightweight. Yeah, most people can manage it, so it's not a bad starter telescope either if you can do that.
Yes, there's a question online from Miguel. Is there any panorama mode available on the Origin?
Panorama. So there's there's no mosaic mode. So Sea Star has a mosaic mode where you can plot out an observation and say, okay, I want to image these and stitch them these several images and stitch them together. Celestron says that's one thing they're going to add to the app. They haven't done that yet. So what you can do is image them, just plan them. And again, I use telescopius.com to take those images, and then you can use a third-party software to stitch them together. So that's how you would create a mosaic or panoramic.
Who has the next question? Any other additional questions? Well, Paul, thank you so much for your time.
All
I
right.
really appreciate it.
Thank you, everyone.
Again, this is like the second time I've heard you significant pieces of this presentation, and each time I am learning new stuff. Thank you very much.